Hello everyone, welcome back. Today, we'll learn about a certain type of sequence and series called arithmetic sequences and series. So we explain what that means and how to work with them. So our goals are to be able to generate these kinds of sequences and series, be able to find what's called the common difference. That's what makes this arithmetic, and then also be able to find the sum of the arithmetic sequence or series. So first off is to recall that a sequence in math just simply means we take a collection of numbers, something like this. So if you have we're going to call these generally A1, A2, ... and AN, basically a list of numbers. And usually they could possibly be random, but usually there's some connection between them. Usually how to get from one to the next one. Then a series is then actually where we just take those numbers and add them together. So A1 plus A2 all the way ... to the last one we're going to call AN. That's where to stop. Or they could also go on forever, but if we stop right here, remember this ... just means continues. Now, if the difference between these numbers is the same in each case, so if you have what's called arithmetic sequence, let's look at that. So arithmetic sequence. So if you have a sequence like this, and it turns out the difference between any two numbers is the same as some constant number, it's called arithmetic. So if we look at that, so we have A1, A2, A3, A4, and so on, once again up to AN. Then if A2 minus A1 is equal to some number called D, and the same too, so A3 minus A2, its previous number, is also some number D, and so forth. A4 minus A3 is also the same number, let's call it D. That's what's called arithmetic sequence, okay? Where the difference between a number in the previous one or the one after it, the difference is some common number, some constant. That's called common difference. So D is called the common difference, because they'll have that in common. That's what defines an arithmetic sequence. So something can still be a sequence without that being true, but that's what an arithmetic sequence means. You know, a common difference. So if we look back here on the left, what that tells us then is that the difference between, if we have some AN, and then just make this general, some number AN and AN plus 1, so basically some number of the sequence and the number after it, that difference is this D, as we said here. A2 minus A1 is D, A3 minus A2 is D, okay? And that also means that I'm having some issues with my speakers, okay? And that also means that you can get from any number in the sequence, add D to that, you get the next one. Well, let's look at a quick example of how this works. Instead of being general, make it more concrete. Let's say it was a sequence like this. So 4, 10, 16, 22, and then ... We keep going. Okay, that's a sequence. Now, so is this arithmetic sequence? So let's find out. So if we subtract these two, okay, so obviously 10 minus 4 is 6. 16 minus 10 is 6. And then, as you can see, as you expect, 22 minus 16 is also 6. So this is arithmetic. And 6 is our common difference. And what that does, that tells us that how to create the next number of the sequence. So the next number of the sequence is essentially be just 22 plus 6. So then the next number is 22 plus 6, which is 28. And then the next one is 6 plus that, and so forth. So you can do that. And I don't know, this technically here is what we're calling our starting point. You can think of any point, any number in the sequence actually as being our starting point, okay? Now, so that's what it means, once again, to be an arithmetic sequence. And of course, a series, we just simply add these numbers together. That makes it an arithmetic series. Now, this next thing, let's find what's called the nth term of the arithmetic sequence. Okay, so what this allows us to do, if we know the first term, and once again, we can actually kind of declare any one of the first term, know the first term, and then we know this common, what's called a common difference D, okay, then we can actually find that it will tell us any term we want, okay? So the nth term of this one, let's do that. We're n is just some general number, so the nth term is going to be, from the formula, an is equal to a1 plus n minus 1 times d, okay? And so we plug in what our, of course, what our d is, or this time is 6, so, and d is equal to 6, and so this essentially becomes just a1, of course, an a1, let's back up, so here, d is 6, and also a1 is equal to 4 in this case, and so an is going to be 4 plus n minus 1 times 6, and just simplify that. And so we're going to have 4 and distribute the 6. So 6n minus 6, and that's going to be 6n minus 2. And so what this tells us then, from this tells us then what any term we pick will be. Okay? So if we want to find the 20th term, so a of 20, for example, then it's going to be 6 times 20 minus 2, which of course is going to be 120 minus 2, which is going to be 118. Okay, so that way we can find any particular value we want. Okay. Now also, let me check something really quickly. Okay. So that's the idea. So that's how we can find, so essentially given any sequence, if we look at the terms and there's a common difference, a common length, common distance between each one of the factors that makes it arithmetic sequence, we can find that common distance. We can also find then any term of that sequence we want, the nth term. Okay. Now let's do a few examples of that, just practicing with these ideas. So let's do a few examples. Okay. So first, I want to this example. Let's say let's find the first 5 terms. We'll find the first 5 terms if we know this. So a1 is equal to 4, and the common difference is 3. Okay, let's start there. So if a1 is 4, then, of course, the next term is going to be 4 plus 3. It's going to be 7. The next term is going to be 7 plus 3, which is 10. Next term is that 110 plus 3 is 13. And then the last one, 13 plus 3 is 16. Okay, and so of course we can go on further one, but if we want, that's it. Okay, next, let's see, take a look at the next example. And okay, this next example, I should call this number 1. Number 2, they want to find let's find D And let's find, let's say, a of 7. Okay, now let's use a sequence here. So let's have -3, -7, and -11. Okay, well, first off, we need to find our common difference, find D. Okay, so basically, we said the common difference is we get from subtracting, like any term, subtracting a previous term from the current term, or basically a future term, the term to the right from the term from the left. So let's start here. It doesn't matter where we start. So that's going to be -7 minus a -3. Okay, from this formula right here. So basically, you subtract the current term from the next term up. And so that's going to be -7. And of course, negative times negative is plus 3. And that's going to be then -4. Okay, in this case, our common difference is negative, and that's okay. Because a sequence could be increasing. It doesn't have to, it could decrease like this one. Okay, that's our common difference. Now, we want to find A7. So first, we know that A1 is equal to -3. A7 is equal to, I'm sorry, A7. D, the common difference, is equal to -4. And so we have a little formula here. Say, so a to the 7th. Well, actually, let's find the common difference first. So an is equal to -3 plus n minus 1 times -4. Okay, this will make it general then. And so we have -3, then distribute the -4, so -4n plus 4, right? And then if we combine our like terms, I'll just write it this way, 1 minus 4n, that's a to the n. Okay, good. So since that's a to the n, then a to the 7th is going to be 1 minus 4 to the 7th, and that's going to be 1 minus 4 times 7 is 28, and that's going to be -27. Okay, this way we can find these terms as we need to. Okay. Once again, I'm just looking at which one I want to do. Example I want to do next. All right. Now let's do something a bit different as well. Number 3. Number 3, what we want to do is want to actually want to find A1 if actually, let me pause this just a minute. I need to check something. So okay, I just had to pause just to check for a second. Okay, so I want to find A1, the first term in our sequence. Okay, but here's what we know. If we know that A12, the 12th term, is equal to 60, and A20 is equal to 84. Okay, if you notice right now, this doesn't really fit any of our formulas really well, because you don't know consecutive terms. You don't know like the 13th, the 19th, things like that, so it's hard to find D right away. And also this formula here, you notice it starts with A1, and that's what we're trying to find, right? Well, what we can do then is, remember, essentially any series like this, we kind of think of it starting anywhere we want. Okay, I'm calling this, for example, the one we just did. It starts, I say, at -3. We could say it started -7 or -11. We still generate the rest of the series in the same way because we have a common difference. So we'd simply subtract 4 from each term to get the next term. What we can do right now to do the answer to this question is let's we're going to call for the right now A12 is equal to A1. You're going to call that 60 in our formula for the nth term. Okay, because we could also essentially start at this term right here. If we wanted to at the 12th term, and if we have the common difference, we'd still get this term Eventually, it would be the 20th term, but it would be a later term. Okay. Now, if we start that, then our n instead of 20, our n for the next term up is going to be 20 minus 12. Okay, must subtract our counter numbers here, and that's going to be 8. Hope this makes sense. So I'm assuming if I start at 12, call this 1, this would then be the 8th term. Okay. So for this formula, I have A1 is equal to 60, and A8 is equal to 84. Okay. Now, let's plug those in for our formula here. And so the nth term I'm going to plug in AN also is 84. Okay, is the 8th term. And so that's going to be 84. Let me write better. So 84 is equal to A1. We're calling our A1 right now our 60. Okay. Then plus N, which is 8 minus 1 times D. And now we have an equation where only unknown is D, so we can actually find D. Okay, let's do that. So subtract 60 from both sides. That's going to be 24 is equal to is equal to 8 plus 1. Actually, hang on, let me see. Is equal to 7D. And actually, hang on, I'm sorry, I have to pause again. I may have gotten a number wrong somewhere. Give me just a moment. Okay, sorry about that. Actually, I realized I made a mistake. So let's actually go back and change this. Let's make this 74. So instead of 84, make this 74. So we're saying 84. Let's turn that to 74. That will actually work better. Okay, so it's going to be 74. Carry that through. So 80, 74, 74. Right. So when I do that, I do 74. Then if I subtract 40, that's going to be 14. And this course is going to be 7. There we go. So then D, I'll just turn this around. Divide 14 by 7, of course, is 2. Okay. Now, okay, good. So now what we want to do is then finally we can find A1. Okay, let's go back to our formula. AN is equal to A1 plus N minus 1 times D. Okay, so how does that help? Well, actually, we can call either one of these a to the n now. Okay, it doesn't really matter. I'll just pick the same one again. Okay, so of course, now we know that D is 2, and let's call A20 once again equals AN, and that's going to be our 74 rather, 74. Keep saying that wrong. 74. Okay, and if that's 74, then let's plug those in, and what we have then is 74 is equal to A1 plus, and that's going to be 20 minus 1 times D, which is 2. Okay, here our N is 20. So plug all that in, and now we have an equation is for A1. So let's simplify everything. So 74 is equal to A1, and that's going to be plus 19 times 2, which is going to be 38. And so A1 plus 38 is equal to 74. Subtract 38 from both sides. And that's going to be, I think, what, 36. Let's check your calculators. 36. So A1 is equal to 36. Okay, so that's just kind of good practice working with this formula, understand how we can use this. And also the fact that in terms of that formula also, as I said, although we're calling that's our first term, basically, in essentially any sequence, we almost think of any term as sequence as being our first term. So if I can look at one of these sequences, because as long as we know how to generate it, then we can start anywhere. As long as we have a common difference, we can start any place we want in the sequence. Okay. Now, next thing I want to do, let's actually take a look at something a little bit different. Let's actually take a look at a picture, and we can determine a sequence from a picture. So give me just a moment. Let me bring this over here. And sorry, I should have see. Give me a second. I have to drag this down now. Just a moment. We're almost there. Okay, so let's say I have this picture. And let me actually shrink it just a bit. I think we can see it okay. So let's have some space to work over here. Okay. So what we have then is just a picture. And a couple ways you can approach this. You can also think of it kind of like as a fitting like on a line, which it almost does, you can see. Okay. We can also approach it the same way we've been doing, and that's probably, I think, some ways the best way to do it. Okay. Now you notice in this axis we have n, those numbers we're working with, and of course is our 8n, our actual sequence values are on the y-axis. Okay. So if we look at this also helps us to find out what's called our domain and range. Let's do that first. So if you think back to other math classes you've had, your domain is usually your x values, okay, along the x-axis, along the horizontal axis. So here, they're actually just discrete numbers. It's not everything in between these numbers, just these particular numbers. For domain, it starts with 1, then 2, 3, 4, and 5. So domain is just 1, 2, 3, 4, and 5, and those are our n's, okay? These are n values. Then our range are actually the values of our sequence, and those are the y values. We're starting, looks like, with -1. Actually, it's looking pressed, a little harder to see. This is, I took this from a textbook. It's not easy to see. So here, looks like -1 is actually right here. That's actually -2. So just be careful the way it's laid out. -2, 0, then 2, 4, and 6. And these are ANs. Okay, those are actually our sequence values. Then our sequence is actually then this -2, 0, 2, 4, and 6. And here we're kind of assuming it stops right here. The picture can keep going. Okay. Well, now if we want to find, say for example, we want to be able to find the nth term, for example. So here we can see our A1 from this is going to be -2. Okay. Our common difference, I think you can probably tell, but we can do it anywhere we want. So we just do, for example, between 0 to 2 or 2 minus 0. So let's just do that. 2 minus 0 is going to be just 2. Okay. So that we can, of course, generate any further term we want. We want to find a to the n. Once again, just use our formula. Is a1 plus n minus 1 times d. And so that's going to be -2 plus n minus 1 times 2. And then we get a little formula for that term. So 1 distribute the 2 is going to be plus 2n minus 2. And so that's just actually going to be, as you can see, so 2n then minus 2, that's actually be 2n minus 4. That's a to the n, okay? So then if we want to continue the sequence, for example, we wanted to find a to the 10th, and that's simply going to be 2 times 10 minus 4, which is 20 minus 4, which is 16. Okay, so from that, this picture, then we can actually do the same thing. So here, just remember, in a picture like this, we're thinking of the horizontal axis like our x-axis. This is being our n values, our counting numbers. And then here, the positions in our sequence, and here our sequence values are actually along the y. Okay? All right, so the last topic we want to tackle in this discussion of sequences is actually about the sum of a sequence. Or essentially, this is essentially a series. Let's go to this last part. So the sum of an arithmetic sequence. Okay, so basically this tells us we have two formulas, and this use the formulas depending on what we know about each one. So if you know the A1, the first term, and you know the common difference, we can find the sum of the first n terms either this way. So if you know A1 in the last term, you can actually find the sum this way, so adding all those up. Or if you don't, you simply know the common difference in A1, you just do it this way. Okay. So let's actually do an example of that, or a few examples. Okay, so number one, let's find S10, which is the sum of the first 10 terms. We're making this then a series, okay, of this sequence. So here we have 8, sequence goes 8, 4, I'm sorry, 8, 6, 8, then 6, then 4. 6, 4, dot, dot, dot. Okay. Now, what do we know? So we know that A1, of course, is 8. And then the common difference, just pick one. So if we do 4, let's start here, for example, 6 minus 8. So this one minus this one is going to be negative 2. So our common difference is negative 2. All right. So we're going to use this formula right here. The second one, since what we know A1 and D. We don't know what the last one is. And so we're going to do this formula. Sn is equal to n over 2 times 2 A1 plus n minus 1 times D. Okay. So now we plug in what we know, and what's going to, our n here is going to be 10. And so this is going to give us S10 is going to be 10 over 2, then times 2 times 8, plus 10 minus 1 times D, which is negative 2, and then just have to simplify this and find out. So remember, order of operations, do it inside these brackets first, and of course inside the little parentheses. And so this is going to be, of course, we can also do this outside without interfering with the order of operations first. So 10 divided by 2 is 5. And then we can also do this without interfering with the order of operations. So 2 times 8, of course, is 16, plus 9 times negative 2. Okay. And so we have 5 times 16 minus 18, which, of course, is going to be 5 times negative 2, which is going to be negative 10. Okay. So it turns out that S10, or that's a sum. And of course, hopefully that kind of makes sense, because as you see, we're decreasing here. We're getting smaller each time. And so we think about, so we're going to soon be having negative numbers. We add these positive numbers together with the negative numbers. Then we're going to end up with, eventually, if long enough, a negative number. Okay, so that's a sum. Okay, how about this one? So number 2, we'll find the sum of the first 120 positive integers. Sum of the first 120 positive integers. Remember, positive integers are numbers, they're not fractions, but basically positive integers can be 1, 2, 3, 4, dot, 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 all the way up to then 119, then 120. Okay. Obviously, you don't have to add all those up by hand. So what can we do? Well, let's find out what we know. So our first term, our A1, is going to be 1. In this case, we know our last term our A120 is just 120. And our last one. And as you can guess, our common difference between these two, each one is going to be 1. Okay. So what we can do then is actually we can use this formula right here. And actually, we didn't have to know D, but that's easy to find. In fact, technically, we can kind of use either one. Let's use this formula. So here, N is going to be 120. So S of 120 is going to be, first I'm going to say, going to use this formula. S of N is equal to N over 2 times A1 plus AN. Okay. And so that's going to be S of 120 is going to be 120 over 2, and times A1, which is 1, plus AN, which is 120. And so that's going to be 60 times 121, and use your calculator, because I don't know that one either. And that's going to be 7,200. So what that tells us, if we add up the first 120 integers, the result should be 7,200. That should be the value. Okay, let's do one more, practicing with these formulas. I think we'll just start down here. Is number 3. Is here we want to find A1 and D if we know that the sum of the first 31 terms is equal to 5,580, and the 31st term is equal to 360. Okay, so this time we want to find A1 and D. We know these two things. All right, so let's see what this fits. So we know the first term. Well, actually, no, we know the sum, and we know the last term. So which one does that fit? Well, basically, the only formula that fits is the first one right here. We know the last term. Because here, we know we're trying to find A1 and D. We don't have enough information for this formula. But here, we know both A1, we know both the sum and the nth term. So let's use this one. So let's use Sn is equal to n over 2 times A1 plus AN. Okay, and of course here, our Sn is equal to S31, which is 5,580. And our AN is our A31, which is 360. Okay, and so let's plug those in. And we have 5,580 is equal to N, and of course, N is 31. Over 2 times A1 plus 360. Okay. Now here, 31, that's actually 15.5, which hopefully this comes out evenly. And then A1 plus 360. Okay. Let's just distribute this. And so 5,580 is equal to 15.5 times A1 plus, and then 360. 15.5 is 5,580. Interesting. Okay. And so if we subtract that, obviously we get 0 is equal to 15.5 A1. And that means that A1 is actually 0. Okay, it's interesting. Not what we expected, but that's okay. You can start with 0. All right. Now we need to find D. Okay, how do we do that? Well, in this case, we need to use the other formula. Okay, so I'm just use the other one. So Sn is equal to n over 2 times 2a1 plus n minus 1 times d. Okay, our once again, our Sn is going to be 5,580, and our n is going to be 31. Okay, so let's plug those in. Okay, so plug them in here. And so we have 5,580 is equal to 31 over 2. And then, of course, that's going to be 2 times 0. So at least it makes it easier in that sense. That goes away. So n, we have 31 minus 1 times d. Okay, and so that's going to be 5,580. So just finish off the steps. It's going to be 15.5. And then that's going to be just 31. It's going to be 30 times d. All right, so let's multiply this. So 15.5 times 30 is 465. 5,580, and then divide that, and we get what d is. Now, in general, d also has to be can also be positive or negative. It doesn't also have to be has to be a constant, but it could also be a fraction of some kind. That could happen. We'll see if it is. 5,580 divided by 465. No, turns out d is 12. Okay, good. All right. So what we've learned today, let's go back and review, is basically we've learned what an arithmetic sequence is. So basically, it's any kind of a sequence where the difference between two consecutive numbers is always some constant number. It could be negative, it could be positive, it could also be a fraction or anything like that, but it has to be a constant. And then we learned to find the nth term with this formula, and also could find also if we have enough information, either the first term or the common difference d this way. Then we also practice with sum and difference of basically a series. So adding up those terms of the sequence is arithmetic sequence, and basically we're able to find the sum, that value of that series, either these two formulas, or could also find a1, an, or also d, those same formulas. So we learn basically the details of how to work with arithmetic sequences in series. Thank you. Have a good day.